this lesson, we will review how to find the sum of the interior angles of a polygon. This is one of my favorite lessons to teach because it's one that students love to memorize and forget as soon as the test is over. But instead of relearning the formula over and over again until you've committed it to your long-term memory, I want to help you understand the underlying principles. We start with our understanding that a triangle is 180 degrees. From there, our goal is to determine how many triangles we can divide the polygon into. So let's start with a simple example, a square. Here we have a square with 4 vertices that I've labeled A, B, C, and D. First, we pick a vertex. I'm going to start with A, and we're going to draw a line segment connecting this vertex to every other vertex in the square. So I'm going to go from A to C, and then A to B, and lastly A to D. How many triangles have we formed? We have 1 and 2. That means a square has 2 times 180 degrees, or 360 degrees. Let's try another example. Here we have a pentagon. Following the same principle, I'm going to connect the vertex A to every other vertex. So we have A to E, A to B, to C, and D. And now you'll see that we have exactly 1, 2, 3 triangles, which means a pentagon has 3 times 180, or 540 degrees. One more. Here we have a hexagon with 6 sides. I'm once again going to divide this into triangles. This time I'm going to connect my vertex A to E, D, and finally C. Notice that I did not connect A to B and F for a reason I'll explain in 1 second. First, let's count our triangles. We have 1, 2, 3, 4 triangles, which means a hexagon has 720 degrees. Do you notice a pattern? 2 triangles can be formed using this method from a square with 4 sides. 3 triangles can be formed from a pentagon with 5 sides, and 4 triangles from a hexagon with 6 sides. Continuing along this pattern, we can generalize that the number of triangles we can form from one vertex of a polygon is 2 fewer than the number of sides in that polygon. Why 2 fewer? When we connect this vertex A to the adjacent vertices F and B, we'll notice that those sides are actually on the polygon itself, which means no triangle is formed. To determine the sum of the interior angles of a polygon, you first pick a vertex. You then draw a line segment connecting the starting vertex to every other vertex except for the 2 immediately adjacent to it. And finally, you count the number of triangles formed and multiply that by 180 degrees. The resulting formula, 180 times n minus 2, where n is the number of sides in the polygon. No matter how many sides your polygon has, the concept remains the same. Now that you know how to derive this formula, you no longer need to memorize it, and you have everything you need to go forth and conquer. Questions? Leave them in the comment section below or email me at prepwithjen@gmail.com.